Viral, we last met in, I think it was 2014. Is that right?
Yep.
And I still remember that this drive in Bangalore was one of the more terrifying moments of my life.
Having grown up with that kind of stuff, you never kind of realize it, but you just see someone who's never seen it before, and to see what a frightening thing it is.
Right. But I tell you, the conversation obviously left a mark on me. Now I'm back and bringing the Groxio audience into the Julia community. What was missing when you created or when you helped to create the Julia language in the first place?
We sort of coined this phrase, the two language problem, which we think tries to sort of capture the essence of what Julia is. That before Julia, you always had this, I'll write my algorithms in Python or R or, some high level of abstraction, and then I'm going to rewrite it in C++ or Java or, whatever be your deployment option there for performance and so on and so forth. And if you step back, it kind of feels silly, like, hey, why are we writing every program twice? And what we really need is a single language that is fast and easy at the same time, so that we can bring people together. We can bring the people who are exploring the algorithms, the specialists, along with the computer scientists, and have them all work together in a single language.
So let's dive into this a second. So I just talked to Huda, who was talking about, she's about to wrap up her PhD, but as she started working on that, her problem was that she was always having to drop into C++ for the performance. And so that's a huge part of Julia, but the performance isn't the only thing, is it?
Absolutely not.
So you mentioned two things. I would say that there's a 3 language problem, right? So the other part of it is, we're into functional programming and into abstraction. So what are the primary differences between the abstractions in Julia and in something like a Python that's a little bit less functional, it's object oriented?
I think programming language designers like Jeff and maybe even Stefan would give you a much better answer than I would. But let me give you sort of my answer from the, from a different perspective, coming from a user's perspective. And I feel that the main difference is the goal, right? Like, what was this thing designed to do? And once you set that goal and that vision, then everything else kind of follows, right? And Python was set up to be a very, with a very different kind of goal than what Julia was. So it's not that Python is inherently slow because they don't know how to make Python fast. It's just that, Guido designed Python to be good at certain kinds of things, and performance was not a goal for him. Whereas Julia was designed to achieve a different set of goals. And, and as a result, it made design decisions and choices that are sort of more amenable and meaningful. It also helps that many of us come from a functional programming, way of thinking, and we believe that it is better. And this is a matter of taste, right? I mean, but we do believe that some of these ideas are better. We are not heretic about it. Like, we are not purely functional only, like, some of the, Haskells and some of the folks who come from the Lisp languages. But like, there are some good ideas here, but we need to be pragmatic and sort of pick and choose what we need in order to build a language that's really good for whether it's number crunching or machine learning or text processing or anything high performance.
So a couple of things I noticed in that answer. The first one is that that you said you're not overly strict about the idea of being functional. And I think that that's so important with Julia, because you can drop down into imperative types of solutions when they make sense. And so as Jeff said, a good program is often 80% functional, right?
Yes.
Right. And so the other thing that you said is that it's built for something. And I love the idea that in Julia, I could type 6x, to the 12th power, and it looks like math, right? Or I could use the epsilon for n, or I could use the plus minus Unicode for variances, and they just seem to work.
Yeah. It's there's an interesting thing about the plus minus sign. So there's a package by Mose Giordano which is called measurements.jl. I don't know if someone already spoke to you about it, but it's so cool because you have sort of these errors that can be captured with a plus minus sign. And then Julia's generic programming and dispatch just kind of lets you propagate these error bars through like your regular numerical code, which was not originally designed to deal with errors. And it's just so cool. Like, but, you know, and I'm surprised every time I see one of these things, I mean, for the first time, and that it just works.
Yeah, it just works. I mean, that's the thing, and it's the thing that surprised me because in for object-oriented languages, they've always promised this code reuse that I've never actually experienced. But with Julia and that multiple dispatch, it happens, right?
And you know, people have known multiple dispatch for a long time, right? Like, we are definitely not the first ones to use it, but we went back and looked at the literature. So if you look at our SIAM review paper, like there's some analysis about other languages in the past that have used multiple dispatch. And it turns out, and this is what I learned from the academic programming language community as well, that Julia has a significant, like an order of magnitude higher reuse in the way it uses multiple dispatch than the languages that came before it. So there's something special about, you know, the nature of problems that we're solving with Julia, and in, you know, sort of the total language design that allows this level of reuse.